Hi, today let's evaluate limits using graphical method. Let's start with our first example here. We have limit of x over 3 minus square root of x plus 9 as x approaches 0. To easily evaluate this limit using graphical method, we will use an online graphing tool called Desmos. So go to your browser and then type desmos.com/calculator. The Desmos has this coordinate system, and we can write the function here on the left side. You can also change the settings of your graph by clicking this graph settings. Then we can change the step of the x-axis to 1 as well as the y-axis. You can also uncheck the minor grid lines if you want, or you can just leave it that way. It's up to you. Let us now write the function from our first problem. You can use the keypad of the Desmos, or you can also use your keyboard. Here, let me show you. Let's type f of x and then equals. Since our function here is rational, we must first click this divide symbol. And then on our numerator we have x, and in our denominator we have 3 minus square root of x plus 9. The Desmos will automatically show the graph of this function. In item number 1, we want to find the limit of this function as x approaches 0. We can plot the points on this graph by clicking this edit list, and then click this convert to table, and then let's first delete the default values of x here, and then we will assign values of x from the left and from the right of 0. Let's start from the left of 0. We know that the nearest integer from the left of 0 is -1. So let's start from -1, and then let's say -0.5 and -0.1. I'm using my keyboard here in typing the numbers. We can continue approaching the value of x to 0. Let's say -0.01, -0.001, and -0.0001. As you can see, the Desmos automatically plot the points. But if we plot 6 points here, since the value of x is closer and closer to 0, the points here are too crowded. But you can actually scroll this up to zoom in, or just click this zoom in button here. We can observe here that as x approaches from the left of 0, f approaches to -6. Let us zoom it out again. We can just use 3 values from the left of 0 so that the points here are not too crowded. We can delete these last 3 values, right? And we can also assign 0 here. When x is equal to 0, our function is undefined. Next, let's assign values from the right of 0. And let's start from the nearest integer, which is 1. Next, let's say 0.5 and then 0.1. Here, we have now 6 points on the graph, 3 points from the left of 0 and 3 points from the right of 0. We can also observe that as x approaches from the left and from the right of 0, f approaches -6, meaning we have the same value for the left hand and right hand side limit of this function. So we can therefore conclude that the limit of this function is equal to -6. You can also take a screen capture or screenshot of this graph here and just choose the part of the graph where the points are present. Here, let me choose this part. Let me click this. We can also edit this screen capture. we say that as x approaches from the left of 0, f approaches negative 6. Likewise, as x approaches from the right of 0, f also approaches negative 6. So therefore, we can say that the limit of this function is equal to negative 6. Let me write the final answer here. Limit of x over 3 minus square root of x plus 9 as x approaches to 0 is equal to negative 6. We can now paste this answer in our notes here, Control V, and here's our answer in problem number 1. You can also save this screen capture here, so just Control S or click the save button and then just save it, say in our desktop here. Let's say answer to problem 1, then click save. So this will be converted into a picture that you can upload online if you want to submit this answer to your teacher. Next, let's continue to problem number 2 here. We want to find the limit of x squared minus 6x plus 9 over x squared minus 9 as x approaches to 3. To evaluate this using graphical method, we just need to repeat what we have done earlier. So let's go to Desmos again, and then let us first delete this table, and we can remove this function here, and then let's write the function in our second problem, and that is f of x equals, since it is also a rational function, click this divide symbol and then write x squared minus 6x plus 9 over, we have x squared minus 9. As you can see, the Desmos will automatically graph the function. If we zoom out this Cartesian plane, here is the graph of the function. But we will only consider the part of the graph where it has x equals 3, because we want to evaluate the limit of this function as x approaches to 3. And then next, we will plot the points. So convert to table. Let us delete these default values of x. And then let's assign values of x from the left and from the right of 3. So let's start from the left of 3, which is 2. And then say 2.5 and then 2.9. We can assign just 3 values so that the points here are not too crowded. We can zoom in the graph here. Oops, sorry. Here. And then we observe that as x approaches from the left of 3, f here approaches 0. Then let's continue. We can write here 3. And as you can see, when x is equal to 3, your function is undefined. Next, let's assign values from the right of 3. Let's start from 4, then 3.5, and then 3.1. Here, we can also observe that as x approaches from the right of 3, f here approaches to 0. So we can say that the limit of this function is equal to 0 because we have the same values for the left hand and right hand side limit of this function. We can take a screenshot or screen capture of this graph here. And then we can also edit this screen capture. Here we can observe that as x approaches from the left of 3, f approaches to 0. Similarly, as x approaches from the right of 3, f also approaches to 0. So we can say that the limit of this function is equal to 0. So let me write the final answer here. Limit of x squared minus 6x plus 9 over x squared minus 9 as x approaches to 3 is equal to 0. And then we can paste this in our notes here. And this will be your answer on item number 2. We have now evaluated the limit using graphical method. You can also save this screen capture and convert it to an image so you can upload it online. So that's the end of our tutorial here. I hope you learned a lot from this video. If you have any question or suggestion, feel free to write them down on the comment section. Thank you for watching and enjoy learning calculus.